This is TechSNAP, episode 372. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on June 14th, 2018. It's brought to you by our three great sponsors, iXSystems, DigitalOcean, and Ting. I'll tell you about them more in a bit. My name is Chris, and joining us every single week is my co-host, the admin, the presenter, and the teacher. It's Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello there, Chris.
Wes, what do you say we kick things off with the theme of the year, speculative execution attacks? A lot of vendors are making the public aware that operating systems and virtual machines that are running on common x86 microprocessors may elect to use a lazy restore for floating point state when context switching between application processes instead of eagerly saving and restoring that state.
Lazy? Eager? Floating point? All right, there's a lot of jargon floating around with this one. Let's start at the high level over at the source, Intel's vulnerability disclosure. From their summary, they write, system software may utilize the lazy FPU state restore technique to delay the restoring of floating point state until an instruction operating on that state is actually executed by that process. Systems using Intel Core-based microprocessors may potentially allow a local process to infer data utilizing lazy floating point state restore from another process through a speculative execution side channel. Does that make it any more clear?
Well, so what it sounds like is that Intel Core-based CPUs have this lazy state performance feature, essentially, that some OSs are taking advantage of?
Yeah, some operating systems, and then in particular, some software systems running on those operating systems. Yes, and it's another speculative execution performance enhancement where normally there's a limited amount of space to be able to store things on the floating point processing unit of a CPU. And when you switch context, when you switch to a different executing process, you can either restore whatever state they had for that immediately, synchronously, eagerly, as you switch context to that process. Or you can utilize these features of Intel CPUs to sort of say, well, okay, maybe that process is never going to use the floating point unit. Maybe it's not going to do any fancy math. So don't restore that. And then if it actually tries to execute some floating point operations, then you can go get its state, load it onto the floating point unit, and then continue execution.
I noticed that TechSNAP creator Colin Percival was tweeting this morning about this particular vulnerability. I think that Intel summary you just cited incorrectly credits him for discovering this vulnerability. He cleared that up. He also just pointed out several other interesting deets.
Yeah, he admits it himself. This should probably be a blog post, but it's actually just a Twitter thread. Now, Colin is obviously brilliant. He's made so many wonderful contributions to the world of security. In this case, he's talking more about CVE 2018-3665, which is the exact issue we're talking about. He learned about it while attending BSDCan and attending a talk given by Theo Durat. So he claims in here that he is not involved in discovering it. He just happened to be one of the first people who took the information about this vulnerability and then actually made working exploit code. He also has some good clarifications about why this matters. Obviously, any information leakage is not ideal, but in particular, the impact of this bug is disclosure of the contents of FPU or MMX or SSE or AVX registers. This is very bad in particular because AES encryption keys almost always end up in those SSE registers.
We are getting really good detail early because it sounds like the disclosure was planned for sometime around August. And I think the reason why we have as much detail about this as we do is because the BSD guys have legitimately been all over this, even though they weren't part of the embargo. And it sounds like Colin was at BSDCan, saw the presentation from Theo, and within 5 hours was able to create exploit code based around this. So it's not a high barrier to entry here.
No, it's somewhere in the middle, I think. You can definitely come up with an exploit. As he says, though, you do need to be able to execute code on the same CPU as the target process in order to steal cryptographic keys, and you need to perform a pretty specific sequence of operations before the CPU pipeline completes, so there's only a narrow window of execution. Looking over back at the Intel's disclosure, they give this a CVSS score of 4.3, which is medium. So, it's not immediately executable. It's not some sort of remote code vulnerability, but it is also still something to pay attention to.
And Linux users might be in pretty good shape depending on the age of their distribution.
Yeah, way back in 2016, those good old days, you might have noticed a commit flyby that made it into kernel 4.6. Some of the notes are, the biggest change in terms of impact is the changing of the FPU context switch model to eager FPU for all CPU types. This makes all FPU saves and restores synchronous and makes the FPU code a lot more obvious to read. It just so happens that a lot of Linux kernels, at least after 4.6, assuming that they didn't make any custom distribution changes to this, are not vulnerable because they are not utilizing this lazy FP load feature.
Yeah, so that really just means your older Red Hat Enterprises and Debian releases may still be impacted by this, but Red Hat says they will be releasing patches for 5, 6, and 7. That's not bad.
Yeah, and I think actually in many cases, if you're on RHEL 7 already, if you're using a Sandy Bridge or newer processor, you're probably already fine. That's the default. If you're using an older processor, you can pass the flag eager FPU equals on and also be protected.
Hey, that's pretty cool. We'll have links that go through all of that in the show notes at techsnap.systems/372. The next story we wanted to start with this week isn't going to surprise any of you. The only thing that's going to surprise you is that the number is as low as it is. But it sounds like the Docker team has pulled down 17 Docker images off of their hub because it was doing things like reverse shells and installing cryptocurrency miners on users' servers. And they've been up for about a year. I'm actually surprised it's only 17, Wes. I would think it's in the hundreds.
If you've been stuck on Mars for the past decade or so, maybe you don't know what Docker Hub is, but it's an open platform where Docker users can push images that they've made. And there's really no requirement that these Docker images go through any sort of security audit or testing process. Once you've made an account, you've logged in, you have your own basically little private registry. You can make any sort of image, make any changes you want, go and push that. And that's all that you have to do.
Yeah, it's not like they go through some sort of vetting process. There's nobody going through each image and then approving it. They just get listed on the Docker Hub right away, and it's just good to go. And then essentially users rely on community filtering to suss out what is well received and well reviewed.
Right, exactly. So you can review, make comments on images, and then obviously a lot of guides or other things will reference, oh yes, this is the official image or not. Most projects that are really using Docker or have made an image available or have a Docker file already have their own sort of corporate or project account on Docker Hub. So definitely pay attention to what account you're actually pulling from, even if it just says, oh yeah, sure, this is Apache. Like, well, is that from the Apache project? Is it from a developer you trust?
Yeah.
In this case, all of the images that they found in this sweep were from the same user using the name Docker123321.
Oh, man.
The unfortunate part about this is some of these packages have been installed more than 1 million times.
See, this is low-hanging fruit that they could have caught fairly easily. If it's stuff that is all from one user account and it's a super generic user account like that, and then you combine that with the fact that there was some signs that started cropping up as far as last September that kept going through winter.
Yeah, users reported that malicious activity was happening on their cloud servers running Kubernetes with the Docker engine. And then some reports of security incidents involving Docker images were also posted on GitHub and Twitter. The number of incidents slowly grew, but it was only after Fortinet and Cromtech got involved that all the pieces finally got put together, and the researchers tracked down all the incidents to the Docker123321 account. Docker quickly removed the 17 backdoored images from Docker Hub. That happened back on May 10th of 2018, a week after Fortinet published the report about a whole bunch of other cryptocurrency mining incidents linked back to Docker images from the same account.
And as you've probably guessed, yeah, they were installing Monero crypto miners. It looks like, at least if you look at one of the addresses, they may have raised a fair amount of money mining Monero. Maybe some of these systems were pretty powerful because on today's exchange rates, they look like they've mined about 90,000 US greenbacks. So it seems to be worth their time.
Right. I mean, basically, you don't really have to do anything. Set up a couple Docker files. In this case, yeah, frequently with miners, or then a couple of reverse shells. And hey, a reverse shell comes in handy. Maybe someone shuts off your miner. You want to go poke around, see what else you can get to run on that system. And yeah, also, a lot of these technologies at play are really there to be scaled, to be, grown autonomously. So if you can just get someone to write in a YAML file somewhere, Docker 123321/ image name, that could see a lot of deploys. We've already said it, but do be careful. Like, you need to treat code like, yes, Docker is super convenient. The ability to pull from the hub and just get software to run without having to install a ton of dependencies is very useful. But you do need to understand that, like, that this code, and many times has access to your systems when you've given it access, and you have to carefully vet any code that you're going to run on your local machine, even if it's in a container.
I still think it's probably way more than 17, Wes, because if there was 17 just on this one account, there could be many more accounts that are doing the same thing. And I think this is the con to the way the Docker Hub model works. The pro is obviously there's a super low barrier for open source projects, free software, and just inspired sysadmins that want to make something available to the community to get it up there and for it to become successful and make a lot of people's lives easier. But the flip side of that level of freedom in a publishing platform is you've got to take on some responsibilities.
Very much so. Yeah, it is really just a public dumping ground of sometimes mostly useful software. And we've all been there, right? You're like, oh, great, someone's packaged this up in a Docker file. I can just go pull this image and run it on the server. And now my problem's solved. I don't have to worry about makefiles. I don't have to worry about all the apt-get dependencies. And it is genuinely useful. But you as the responsible admin, you as the responsible developer need to understand that you're just pulling code from the internet. And in many cases, that's fine, right? If you're pulling it from a trusted source like you would from other dependencies you pull from the internet, okay. But the process is the same no matter what you're doing. Audit what you're using, understand the code that you're relying on, and just be careful.
And the last thing we want to touch on today is a really fantastic post by Netflix where they cover building observability tools and the different things they've tried. They say their growing global member base of 125 million members can choose to enjoy their service on thousands of types of devices. If you consider the scale and variety of content, maintaining quality of experience for all the members, it's a really interesting challenge because you have people on a smartphone all the way up to HDR 4K televisions. They say they tackle that challenge by developing observability tools and infrastructure to measure customers' experiences and analyze those measurements to drive meaningful insights and higher-level conclusions from raw data. In other words, by observability, they mean analysis of logs, traces, and metrics, and then they can base decisions off of what they learn. It's fascinating how they've built all this stuff.
One thing I've, for a long time now, admired about Netflix is they really understand that tooling goes a long way. They've got another great write-up up recently just about their transition to DevOps, how they do DevOps internally. And one of the cornerstones of that is really awesome tooling so that you can give additional responsibilities to developers to own their, the full stack and operations of the things that they develop, and not have to have them learn all the rest of operations, right? So if you have the right tools, if you have really well-designed tools from a central team that really understands those issues in depth, but can export those capabilities, you get a lot of leverage out of that. And in the same vein, when we're talking about observability, when they're talking about understanding these complex systems, tooling goes a long way. They started their tooling efforts just trying to provide visibility into device and server logs, as so many of us do, right? You want to go understand. You don't want to have to, eventually you get sick of just doing a bunch of greps, tailing the same log over, and you realize you need something a little more detailed, a little more insight, a little smarter.
Yeah, in the case of Netflix, they built some really neat stuff in the back end. And then on the front end, they even talk about how they created particular UIs for different audiences within the company. But it all really kind of started with logs and scaling log ingestion.
Yeah, exactly. So even with nice tools, if you're still thinking about a per server sort of concept, that's not going to work. And at some point in their business growth, storing device and server logs, it just didn't scale anymore because they just had too many hosts, right? The increasing volume of log data just caused storage costs to balloon and query times to increase because at some point there's just more noise than data. And how are you going to get through that?
How, Wes? Why, with great tools, new infrastructure abilities, and things like SQL. That's how.
Exactly. So if you haven't already heard, they've got a neat tool called Mantis, and that's a real-time stream processing platform. So instead of saving all logs to persistent storage, which, as we just mentioned, is A, expensive and B, pretty slow, Mantis enables users to stream logs into memory and then keep only those logs that match specific SQL-like query criteria. Users also have the choice to transform and save matching logs to persistent storage. So you can think of Mantis as this big process. You just throw streams of data at it. Then you can set up filters and hooks that look for specific things and then optionally go save those for later analysis persistently.
Yeah, that is so cool. And they say really the key takeaway here is just storing all of the logs in persistent storage. It does not scale in terms of cost. And another big one, acceptable query response time.
Yeah, exactly. And when you're trying to debug an operational issue, you can't wait 10 minutes to go find out like what the result of that query is. You need to find out what's happening in the system right now or as close to now as you can get.
Sure. Picture the service support representative who's dealing with a frustrated customer, and you have a really high-level dashboard for them. And then when they have to escalate it to technical support within the company, that person has a much more details-oriented dashboard where they can do real-time analysis. And then if you have to then from there punt it to somebody on the system engineering team, they're looking really at a really low level amount of detail. It's a really cool concept, and in each stage you can get great insights for the right position.
But sometimes logs, they're just not enough, right? So as applications migrated to a microservices architecture within Netflix, they needed insight into the complex decisions that all of those services are making, and an approach that could actually correlate those decisions. They were inspired by Google's Dapper paper on distributed request tracing. You may be familiar with some open source projects also inspired by that, things like Jaeger from Uber or Zipkin or just Open Tracing, which is a sort of standard interopt between those tools. So they embarked on implementing request tracing as a way to address all these complicated needs of observability into microservices within Netflix. Most inter-process communication at Netflix uses HTTP or gRPC, so they implemented request interceptors for both of those protocols. These interceptors then publish all their trace data to Kafka, and then a consuming process writes trace data to persistent storage. Now, at its core, a distributed request trace provides really kind of just basic utility because a lot of what you have is just sort of a call graph, which services are calling which services, and then some basic latency information. You can maybe look at what's in that request, what the parameters were, how long it took, which process was calling which. What's unique about Netflix's approach is that they allow applications to add additional identifiers to trace data very easily so that multiple traces can then be grouped together across services. For example, for playback request traces, all the requests relevant to a given playback session are grouped together by using a playback session identifier. Right there, that just sounds super useful, right? You just can basically do a search in their UI for one playback identifier, go see all the different events, all the calls between the various services that have to happen inside Netflix to make that video play on your TV.
Yeah, really. So in summary, what they're really saying is they're tying multiple types of request traces into one logical concept, and you hit that, boom, all HDR on iPad, and you get all those results.
Yeah, exactly. The other thing I thought that was really clever and I would love to see more generally used is they've implemented something they call an analyzer, and its goal is to answer common troubleshooting questions. So if you have questions about a playback session and why maybe it didn't get 4K video or why it wasn't offered HDR, analyzers will try to interpret those request trace automatically and see if they can answer some simple things, like, software was too old, wrong firmware version, or just the client had a bug, right? Whatever sort of common questions, if you can get those out of the way and not have to waste the time, because when you're digging into these things, usually it's something important, and the faster you can get a result that you don't have to go dig through meaningless data, the better.
So what you just described there isn't Atlas. I've heard Atlas is a tool that Netflix built, so how does Atlas fit into all of this?
I know, right? It can get a little confusing because we've already talked about logging. We've already talked about distributed request tracing.
Mantis.
Yeah, Mantis.
Now we have Atlas.
Now we have Atlas. And Atlas's goal is metrics. Because observability should also involve analysis of metrics. And a lot of times that's a little bit higher level, right? And that lets you see trends across your whole fleet, across all of your services, aggregated, diced up, viewed, however you need them to go. And without all the granularity of an exact request log, instead you can just see counters and gauges about how many requests am I processing? How full are my queues? Sort of things like that. Now, Netflix for a long time has been using their own open source tooling for this, which they call Atlas. And it enables their users to quickly see macro-level error trends using multiple dimensions, such as device type, geographic location, basically however you want to mix and match those sorts of tags. It also lets users set up alerts if a given metric exceeds a threshold, and they even have some Holt-Winter type algorithms involved so that you can set dynamic thresholds based on past behavior. And that includes stuff like interesting statistical algorithms that detect anomalies in metrics trends, especially comparing to some sort of baseline that you've established.
And speaking of Mantis, a user can define metrics derived from matching logs and then publish those to Atlas.
See, there you go. It's that sort of high-level interop and ease of use that you don't have to make a custom extender. They've already thought of that. As a user, you can just plug and play between these tools and set up whatever is relevant for you. And that's really one thing that strikes me here, because as always, when you're making custom products, there's going to be a lot of specifics. And then especially whether you're building them in-house, using tools in-house, or leveraging open source software, there's just going to be customization that you have to do for your unique system. And that's where having flexible enough tooling really matters.
Okay, so let's talk for a second about how they hang on to all this stuff, their data persistence. They say they store data used by their tools in Cassandra, Elasticsearch, and Hive. They choose a specific database based primarily on how their users want to retrieve a given data type and, of course, the write rate.
Yeah, right. And that's the thing, is you really there's a lot of different data sources for all of this data and all these applications. So if you have observability data that's just always retrieved by a primary key in a time range, if you're just sort of narrowly defined data like that, Cassandra is a great choice. If, however, you need to query something with one or more fields, you sort of have more complex, less tied down, a little more amorphous queries that change over time, Elasticsearch is a good option because multiple fields within a given record can be easily indexed. You can change those. You can re-index as you need to go on the fly. It's very flexible. But of course, sometimes you have data that's just you need to access all the time, right? So recent data, things like the last week, is usually accessed a lot more than older data, which is maybe only used if you're trying to investigate, what happened 6 months ago, or you're just trying to establish some sort of baseline trend. So to serve the use cases where someone just wants to access recent data, they have, that's pretty easy. When you want to access older data, they stick that in Hive. And then that provides different access requirements, makes it a little easier to access without having to keep it in the more real-time systems. Now, of course, each of these systems have their own advantages and disadvantages in terms of cost, latency, and queryability, right? So Cassandra provides the best, highest per record write and read rates, but it's restrictive for reads because you must decide what to use for a row key. In contrast, Elasticsearch and Hive both provide a lot more flexibility. Elasticsearch lets you index any field within a record, and Hive has a SQL-like query language which allows you to match against any field within a record. Elasticsearch is primarily optimized for free text search, so its indexing overhead during writes will demand more computing nodes as write rate increases. So if you have a whole bunch of content, maybe it's going to be too much for Elasticsearch, but if you have specific content that you need that extra flexibility on, it can be really useful.
Or throw a lot of compute power at it. Whereas Hive stores records and files, so reads are relatively much slower than Cassandra and Elasticsearch, but because Hive has to scan those files, so it doesn't have the speed, but it has a pretty low compute cost and storage cost, and so it kind of wins there, especially when multiple records can be kept in a single file and the data isn't replicated. You can really save on storage costs.
Yeah, I think this is interesting too, because now Netflix does have its own unique scale. They have a lot of talented staff. They have a lot of engineers, and they have, a truly global presence. So it makes sense that they would have these. Maybe at some smaller companies, smaller operations, you wouldn't need all three, but it is a good case for use the right tool for the right job, right? And depending on what your actual constraints are, sometimes you just do need different platforms, and you then have to, have to handle migrating data between them. How do you age out data, invalidate caches, that sort of thing. But it does pay off for the user experience in the long run when they have the right data source for their needs at the right time.
do.co/snap. Go to DigitalOcean's landing page to get a $100 credit. When you go to do.co/snap and sign up with a new account for 60 days, you'll get a $100 credit to try out DigitalOcean's blazing fast, super reliable, and well-priced infrastructure. It's a free gift from DigitalOcean to you, and you support this show. They have industry-leading price to performance, predictable costs and billing, and optimized compute types. My favorite system, 3 cents an hour, and they also have those new flexible droplets. They have storage you can attach as you need it, and I've been expanding my usage of Spaces recently while while I'm on the road as a way to quickly send folks files using DigitalOcean's blazing fast systems. They have 40 gigabit connections coming into each hypervisor, enterprise-grade SSDs, and they have data centers all over the world. They manage all of that with a simple but powerful dashboard and a clean, well-documented API. With a 99.99% SLA, cloud firewalls that block traffic at the network level, and documentation that's so good it'll blow you away. In fact, just 20 hours ago as I record this, they posted a brand new guide on how to autoscale GitLab with continuous deployment using GitLab Runner on DigitalOcean Droplets. Very valuable, and of course GitLab is blowing up these days. Check it out at do.co/snap. And an enormous thank you to Ting for sponsoring the TechSNAP program. Not only have they been with us for so long, but they are making these roadshows actually possible. Ting is smarter than unlimited. If you use less, you pay less. The average Ting bill is just $23 per phone per month. You pay a fair price for however much you talk, data, and text. That's it. You just pay for what you use. It's $6 a month for the phone and what you use. It's so simple. The rest of the industry would have to go like this if we hit the reboot button, if they weren't entrenched, and there's only one way to fix that. That's voting with your wallet. Ting has nationwide coverage, no contracts, no early termination fees. Oh, and they have CDMA and GSM networks available, which rocks. You're in control all the time. You can see your usage at a glance. They have a control panel that is clear, simple, but yet, guess what? Powerful, my favorite kind. You can set usage alerts, and when you get stuck, if you ever need help, they have fantastic customer service. Nobody does it like Ting. They didn't start out as some entrenched carrier. They're two cows, and two cows looked at the mobile industry and said, we know how we can do this better. They put the customers first, and they let you pay for what you use, and they back it up with great customer service, and they're geeks. They're geeks about phones. In fact, on their blog, they've just posted their guide to Motorola cell phones, why they love the Moto phone so much, including a comparison to the Pixel 2 as well. So check it out by going to techsnap.ting.com. And there is only one hardware provider I recommend for your infrastructure, for your projects. It's iXSystems. iXSystems.com/TechSNAP is the landing page to go to support this show and learn more and grab the ultimate guide to buying a new server for an open source software deployment. iXSystems can build a custom solution for any category of office, enterprise, or even in education. iXSystems are the folks behind FreeNAS, the project we all talk about and love all the time. And what you might not have known is they're also the folks behind FreeNAS's bigger brother, TrueNAS. It's a cost-effective solution with enterprise features that protect and serve up data for years. In fact, take the education market, for example. You guys know I have a soft spot for that. TrueNAS can be particularly flexible in the education market because it supports both SAN and NAS protocols, so you can have multiple block and file protocols in one NAS. That gives you flexibility in your choice of applications while reducing the number of storage arrays you even need. Every common operating system, hypervisor, and application is supported. Instead of having to create storage silos for various applications, you can use one TrueNAS storage array. That's amazing. And it's all using OpenZFS, and it has the backed support of iXSystems and their white glove process from sales to years after you have the rig in the rack. Check them out at iXSystems.com/TechSNAP. That's where you go to support the show and learn more. And while you're there, go visit the iX blog. A couple of fantastic posts went up on June 13th. They're recaps from BSDCan 2018 and Self 2018. And you know that BSDCan recap is sharp, including some of Alan Jude's talks and more. Go to iXSystems.com/TechSNAP to support the show and begin a process that's going to save you from so much headache, so much fiddling with hardware. They're the only server hardware provider I recommend. iXSystems.com/TechSNAP.
Thanks for going to techsnap.systems/contact to send us your feedback, questions, comments, concerns, or just general feedback.
Or war stories. Heyo! A lot of people like the war stories they tell me at Texas Linux Fest.
Excellent.
We need another round.
We sure do. And that's the sort of organically sourced bespoke content that we rely on you, dear audience, for. Sure, we've got our own, but we got to dole those out carefully. You guys have the best content.
like this first question we're going to answer, and I bet this might be on some of your minds out there. He writes, for the past 15 years, I've been in various Microsoft systems engineer admin roles, focusing on Windows Server infrastructure, Active Directory, failover clustering, and Hyper-V virtualization. For the past year, I've been helping a company migrate their on-premises VMs into Azure. I'm working with various recruiters, and I've been seeing more and more DevOps engineer positions, and positions that require automations with tools such as Puppet, Chef, Configuration Manager, etc. In my opinion, DevOps is supposed to be developers testing and deploying their own code and troubleshooting that code when it breaks. And that's all fine with me. But it seems like companies want systems engineers and admins to start doing that. As a system engineer, my background and interests lie in Windows Server infrastructure. I have no interest in coding or automating. I find it boring, unless it's a quick and dirty PowerShell script to automate a task. In my opinion, DevOps is a position that companies created to get one person to do the job of two, when these two should be separate positions. If system engineer positions are moving away from traditional infrastructure design and support and more into DevOps coding automation, I'm inclined to start looking for positions outside of system engineering. Maybe a project manager? What are your thoughts on this? Any advice for a system engineer who doesn't want to do DevOps coding or automation?
Boy, there is a lot to unpack in that question there, Chris. One thing that I think just right off the bat is hard about these kinds of discussions is DevOps is a term that means everything and therefore nothing. Not that there aren't legitimate meanings, because there are, right? There are a lot of things in the DevOps SRE world that are meaningful, but it really depends on specifics related to your operation, your organization, your company, because different strategies make sense at different levels of scale, and really it also depends on, what resources you have, what training you have in-house, what expertise you have, and how your systems are managed. Some people are running a really simple sort of WordPress website where automation is relatively straightforward, or you're doing something more real-time and it's a lot harder. All those sorts of things come into play when you're deciding what positions make sense and who has what responsibilities. That said, I do think it's important to think about things in terms of actual operations and then the life cycle of how code gets deployed, how things are run. It's perfectly reasonable to not want to be involved with that and just be someone who's an expert in systems engineer, in hardware, in data center management, because those are all very useful and at many companies will still be necessary. In those cases, then your job becomes providing some sort of interface or having someone above you that works with the hardware that you enable so that developers have an easy to use, clear interface so that they can self-manage, self-utilize the things that you are directly responsible for. I think the big pain point for a lot of the developer side here is that people in 2018 don't want to submit a ticket to get a new VM built for themselves. They want to go to a self-service portal or make an API request just like you could do in AWS to get the things you want because you're going to manage them. Now, that doesn't mean they need to understand on what server it runs or be concerned about what hypervisor is in use or all those low-level details. That can be on you. But I do think it's important to have expectations of automation, consistency, repeatability, auditability within your organization. If that's not the role that you want, if those are not the things that you want to specialize in, that totally makes sense. And then it does mean that there do need to be people who specialize in those tools. It does get a little more complicated in cloud-first shops because there is still a lot of that sort of low-level stuff to happen. It's just in a different world. It means managing the VPC, managing all of the little knobs that exist in AWS to tune. And that may not be the thing for you either. Right? And that's where it does get a little hard because the titles we have in a lot of this industry are way too broad. So it doesn't, you can be a systems engineer who manages purely cloud resources, or you could be the guy who's running and working on fiber channel switches in the data center. And those can be completely different specializations, and you might not be interested in one or the other. So it just becomes harder. I think systems engineer still could be the right title, but you just need to be more careful about during interview processes, while you're looking at companies and responsibility lists, what are you willing to do? What are you interested in? And be clear about that through the whole process.
Wes, I really couldn't add anything to that. I think that was really all on point. The one thing I will add is maybe it's time for a new gig. I'm here at Linux Academy, and they're prepping a whole bunch of new content for July. This isn't an ad. I'm just telling you side story, they're also hiring, including they're hiring security experts and whatnot. They got several open positions right now, including like a Linux QA position and a couple of others. So I'll put a link in the feedback section of the links for some of their job openings on LinkedIn. It might be worth maybe a time for career change.
I can't think of a better place to go pick up skills, or if you've already got them, go share with the world.
Well, before we wrap up feedback, one more plug for the war stories. We love reading those on the show, techsnap.system/contact. Also where you go for the questions and the follow-up.
Thanks so much for tuning into this week's episode of the TechSNAP program. If you'd like to find more, just head on over to techsnap.systems/subscribe. You can find all the great ways to find us right there. Or if you just want a simple RSS feed, that's techsnap.systems/RSS.
Yeah, plug it into your favorite podcast catcher and enjoy the chapter markers. It's something we haven't mentioned for a little while because we've just all gotten used to it, but it's something that we didn't used to do on the program that we do now, so you can jump right to the section that you want to hear, or replay a section if you missed some details. I love those chapter markers, and if your podcast player doesn't support chapters, they might just need a little nudge, because I think more and more podcasts will be adding them soon. And you can catch more Wes Payne on the Twitter. He's at Wes Payne. I'm at Chris LAS. And the whole darn network is at Jupiter Signal. Wes and I will be traveling next week, so there may be a slight disruption in the publishing schedule. If that happens, we'll try to do a make good, though. And of course, as long as you're subscribed, you'll always get a new episode when we publish it. But in the meantime, thanks so much for tuning in this week's episode of the TechSNAP program, and we'll see you right back here
next week.